My name is Doug Purcell. I'm an independent software engineer located in Southern California, and I'm also a technical book author. And today, I present you my talk, The Insider Scoop to Beautifulsoup. All right, so just a quick show of hands. How many of y'all know what Beautifulsoup is? Okay, so roughly about 50% of my audience, which is good because that makes my job a little bit easier. But Beautifulsoup is a package in Python, and as you can see, hopefully your packages for Christmas doesn't end up like this. But Beautifulsoup allows you to parse web page documents like HTML or XML. Okay, so here's a good non-technical example of what parsing could do. Let's take something that we're kind of familiar with, like the English language. If you have a sentence, it could be decomposed to several parts, like verbs, adjectives, nouns, etc. So in a similar concept, a web page could be broken down into HTML tags. And once we have that web page read in the DOM, like a document object model, we can go ahead and parse it. So why Beautifulsoup? So Beautifulsoup is, according to the company that makes it, Crummy.com, it can parse anything. So I like to take it a step further and say that it could parse even the most grotesque or most nastiest HTML. And on a good day, it could probably parse titanium as well. It's also compatible with third-party libraries like LXML or HTML5lib. And also, Beautifulsoup is quite simple to get the hang of, it's easy to install, and it's very intuitive to use. All right, so to install Beautifulsoup system-wide, we could use the pip package manager. So we could do pip3 install Beautifulsoup, and then once you put that into the terminal or command prompt, the packages will install. And then you can test the installation just by importing the Beautifulsoup file. So from BS4, import Beautifulsoup. And I made a quick screencast, but we can skip that into the meantime. And I'll show quickly how to integrate Beautifulsoup with PyCharm. So the reason why I chose PyCharm is because PyCharm has a wide mindshare in the Python community. A lot of developers use it, and so do a lot of companies. So I figured to go ahead and show the rest of this tutorial with PyCharm. Well, I had a video for you guys, and I have to access it. Well, I'm on a different computer, so sorry for the technical blip. I will go ahead and post the slide deck online after this event, so you can have the information on how to install PyCharm, how to integrate Beautifulsoup with PyCharm. But in the meantime, we'll just move ahead and we'll walk through like a simple demo. This right here, just HTML document that I uploaded on GitHub, and this allows you. We're going to use this example to parse the HTML document. So here's a quick example of a very simple HTML page I created. As you can see, it has the proverbial header documents. It has the doc type, it has the HTML tag, and it has a very simple table. So in PyCharm, we can create a project, and then we can go ahead and create a new Python file and call it something like soup.py. And then from there, we can go ahead and add the HTML file that we talked about in the previous deck to the same directory. So once everything is added, this is how it should look. You should have the folder, I call it web scraping, and then you have the HTML file, and then inside the HTML file, you have the Python file as well. So here's a very just simple example to illustrate Beautifulsoup. So here we import the Beautifulsoup library, and then we create a function. Inside the function, we create the Beautifulsoup constructor, and then we also open the file, and we pass the file into the constructor. And then we return the soup, and then we call the prettyfy function so that we can format the code. So the output looks just like the typical HTML file that you read in. And this is not very helpful, even though at this moment, because the purpose of parsing is to extract specific elements of a web page. So we can go ahead and make a simple modification to this function. Instead of returning instead of return just a soup.prettyfy, we can return a soup.table.prettyfy, In this case, we're able to return the table in the HTML document. And this is how the output looks when the code is ran. And then we can also get a little bit more granular. We can return a row inside of the HTML document. So if we go ahead and the only modification I made to this code, which is that we return the soup.tr, and the .tr are built. That's a built-in attribute inside Beautifulsoup. So all the HTML tags like the .tr, .td, etc., those are built-in attributes inside Beautifulsoup, and we could call them to access certain elements. But the issue is that there's one problem with this code, and do you want to know what that issue is? Okay. Oh, do we have a reason? Someone want to say? Oh, okay, no mind. Okay. Okay. Actually, no. It's kind of like something kind of like minuscule, but the problem with that one is that it only returns the first occurrence of the TR tag. So if we want to return all the TR tags, then we can use the find all function, and then we can pass in the tag that we want to return. In this case, TR. So the only thing we updated was we used the find all function, and then we pass in the tag that we want to return, and this returns all the TR tags inside the table. Oh, skip one. Okay. And also, so in the previous code examples, we returned pretty much all of just the tags of the HTML document. And the problem with this is that the diamond brackets are attached to it. So if we want to return just the content inside the tag, then how do we do that? Well, one example is that we can again use the find all function inside of Beautifulsoup, and then we can print the content, and we can use the built-in method in Python, which is the join method. And this allows us to pretty much pass a string through the tags. So this way we'll get the content. We get the content and no brackets. And let's take a quick real-world example. So how many of y'all like Reddit.com? All right. I'm surprised to be more. Okay, well, I like Reddit as well, but unfortunately, I don't have the time I used to analyze it. So therefore, what if I want to analyze just all the H2 tags, or pretty much all the tags on the homepage of Reddit, and maybe export it to a text file so I can analyze later? Well, I can use Beautifulsoup for that, and in conjunction with requests. So requests are just a built-in, it's not built-in, it's a package that can be used for HTTP requests in Python. And in this example, I created just a function, and we imported requests, Beautifulsoup. Then we create a function with headers that mimic a user agent. If we don't mimic the user agent, then Reddit might block our script from running. And then we go ahead and pass it to the get function inside requests. And then from there, we go ahead and open up the file, and then we create the Beautifulsoup constructor, and then we can iterate. So probably the most trickiest part of this code is the for loop. And it helps to have a little bit of understanding of HTML, because if we want to parse a particular website, we have to understand a little bit of the structure. And Reddit is a pretty complicated website. There's a lot of stuff happening. So I'll go ahead and cut this short, and I'll say that by analyzing the source code of the website, I noticed that all the content on the front page were in H2 tags. Inside the H2 tags were a class that contains that has the name of imors3.0. So inside the for loop, I drew all of the tags that matched those parameters, and then I just print it out and export it into a text file. So if you run this code and you run right now, what will happen is it'll be a text file would be generated that has all the headlines from the Reddit front page. So this pretty much concludes my presentation, and I'm very happy to be here. I'm a big fan of LinkedIn, and thank you guys very much for having me. Merry Christmas, Happy New Year to you and yours. And as a token of my appreciation, I'll leave you guys with this. Thanks, guys.
Yeah, one of the talks, one of the requests we get from the audience, who sometimes we get new people who come and like, I want to figure out how to actually get some information from a website. How do you do the web scraping thing? So this is a common request we've gotten. That was a really good lightning talk. Thank you. And so I really like the idea of doing social good. I think we're going to hear more about that. And Chris, I'm going to let you introduce yourself. You want a couple more minutes to get set up? All right. So we are actually going to talk a little bit about social good. We're going to see how that works, and we're going to probably learn a little bit about some data science.
A little bit of try that. How's that? Is that better? Okay. All right. We're doing good. Swap it out. All right. Great. Welcome, everybody. It's nice to see people and some friends as well. I'd like to just say a quick thank you to LinkedIn for their continued hospitality through the year. And it's nice to see everybody so close to the holidays. So I'm Chris. We're going to talk about using Python and data science for some social good. Just a little bit about me for those of you who don't know. I'm the founder of SurfaceOwl. It's an enterprise AI company in San Mateo. Do a little bit of data science with that. And I also do some consulting on machine learning pipelines in AWS with Noah, who was a speaker here a couple months ago. I'm also a recovering consultant. I was at Accenture for much longer time than I care to admit to you fine folks, and an engineering officer at the Air Force before that. I have a little bit of an engineering background. But I have been in California since the mid-90s, and I love it here. So the project we're going to talk about is a project I'm in the middle of with the UK government. It's for a group that's called the Community Rehabilitation Company. And essentially, this is a privatized entity that's responsible for taking parolees and making sure they go through their court-ordered office visits, for a year or 2 years, however many years that's going to be, or people who have court-ordered community service. In lieu of going to jail, they're going to do some things for the community for a couple hundred hours or something like that. Now, as it turns out, there's a lot of people in this program. London's a big city, first off, so let's recognize that. There's about 40 to 50,000 people at any one time kind of in this program in some form, okay? That's for the District of London. If you know a little bit about the geography, the City of London is actually this tiny little island. It's a few city blocks, and so this is kind of for the major metro area, and the whole UK is divided up like that now. Yeah, so we're going to talk about this project, and just a couple disclaimers. So Europeans, as all of us should be, are very keen on privacy. So all the data that came to me was kind of cleaned and sanitized before I even got it. And then for this talk, since it's a sensitive topic, I did some anonymization and randomization further. So we're not actually looking at real people here. We're looking at distributions of people that look very much like the stuff that I worked with. And so before we start, when you're doing a data science project, the first question you want to ask before you lay down any code or look at any data is what questions are we trying to answer? There's two big questions here, and we're going to be able to address a little bit of the first one. The second one's still in flight. The first question is, what is the current state of this operation? And to set the context, the situation is this. This agency's been around forever. They have some green screen programs. They have a lot of Excel. As they got Tableau like a year ago, but they don't really have the bandwidth and the skills to use that. And also, there's only so much you can do with a bar chart, as it turns out. So and they've been a little challenged to figure out what do they do to improve their operations. And the improvements they're looking for are very specific. First, they have these office visits. People only attend 40% of the scheduled visits. Not good. They have community service projects. A lot of people finish them. There's also big populations that kind of drop off the radar and don't finish them. And in all of those cases, those individuals end up back in court. So it's not good for them. It's not good for the government. They spend money, etc. So the idea here is by being a little bit more analytical and outcome focused on the operation of this process, maybe we can get more people to show up to their office visits, stay out of court. Maybe we can get more people to finish their community service stuff on time and everybody's happier, right? So that's the goal. And the agenda for today, we're going to try and cover a lot of ground. And what did I just do? Yeah, I don't know what I just did. There's a bit too much of a zoom there. And I don't want that. All right. There we go. All right. Hopefully you can read that. Still figuring out the whole Rise JavaScript scaling thing with Jupyter Notebook. It's not quite perfect. For me, anyway. There's 4 things we're going to talk through. And I'm going to move through relatively quickly so we can talk afterward if there's other questions. We're going to talk about some EDA stuff, in particular a library that I think you'll find is pretty interesting. We're going to look at an API I had to use to help validate locations and get some geodata, and hopefully that code runs while we're here. We'll also look at using the Google Distance Matrix API, which is part of the problem that we're solving. We want to figure out, hey, how far is it? How long is it going to take these individuals to get to these different projects? Because maybe if we put them on different projects, they can complete their stuff more quickly. And then finally, the client wanted to see some maps of this stuff, which they weren't able to get themselves given the current state of the data, so we built that for them. All right, so data cleanup. We got a bunch of data. It was in Excel. It wasn't great. There's kind of 3 things to take away from this slide. Chunk of data on users for community service, chunk of data for office people need to go to those visits. We have a chunk of data on the projects that, of course, isn't in one file. It's broken up in different files. One of them tells you where the projects are. The other one tells you kind of useful characteristics like when is the project offered? How often does it happen? What's the utilization? Is it a full project on average? Is it half full? Is nobody showing up? That kind of stuff. And then finally, where are all these offices, right? So an interesting thing that I learned, and Neil brought us to this just a minute ago. So in the US, we're used to zip codes, and I thought, oh my gosh, a zip code. There's 1 billion people in there. In the UK, it's much, much different. So I live in San Mateo. Each zip code is probably like, this is the national average up here. In San Mateo, there's probably like 30 or 40,000 people in my zip code. In the UK, it's going to be more like literally 30 or 40 in a postcode. So think of a postcode as like half of your block or something like that, right? And so the implications on privacy are actually, they're important, because if I have a postcode and you're looking for a white male whose age of X, it's Chris, and so you're just going to know because there's only kind of 30 people to kind of choose from, right? So that is a consideration. And now, finally, we're getting into some code. So the first thing I had to do is kind of read in this data, pretty basic stuff. So using pandas, we're going to read in this stuff. I like to cast all the columns to kind of just make it easy to read and avoid kind of spelling errors and stuff like that. Take a quick look at what we have. And so dfinfo is the standard command for that. And basically that just gives you, in this data frame that you just imported, what are the columns, what are the data types of those columns, and how many kind of values are there. So it tells you kind of what you have. And we are going to focus on 3 of these in a moment. And well, I guess we're going to jump into this one. The next thing that I'd like to do is look at automatic graphical visualization of what's in this thing, right? So you can spend a lot of time kind of doing commands and kind of looking at data and stuff like that. But I like to kind of start high and say kind of what's the lay of the land. So looking at this, we looked at these 9,000 records and we see that mostly the data frame is complete. Everything has values in all of its columns, except this one in the middle, this number of stand downs, which, as it turns out, is a little bit important. A stand down happens when a person shows up to a community service event, wants to do the work, but they only can support maybe 10 or 20 people, and they're number 21. So they get turned away. And you can imagine if you're trying to work through your community service, that happens a couple times, you get discouraged, maybe you stop going, right? So we want to kind of minimize that. So the other thing we see though is good. We've got all of our elements are filled in all these rows. So obviously everything's going to be great with all of those other columns, right? We go and, was there a question? I'll laugh, no. So as it turns out, that number of stand downs just had a lot of 0 values, and the client said, yeah, those are for people who haven't missed any. So we can just kind of zero those things out. When we look at that data in specific, what I like to do is kind of take a look at all the unique values in that column and just do a frequency count so I can get a sense of, like, just in this column, kind of what do we have? You can see that, hey, if you're stood down one time, there's 1,300 people just in this set that were stood down at least once. So that's 15 or 20% of our population. So of these 9,000 people, 20% chance you're going to show up at a project and get turned away. You start looking at that happening multiple times, you come up to, I don't know, 3 or 4 times getting turned away. That's going to be closer to 2,000 people, and it grows from there, right? So this is an issue, and this also shows us that, you know, by looking at the data and understanding what's in there, we can make some good decisions about where to spend our time doing some analysis. Now, another area that we looked at is this column. Last attended band is a code that was in our previous graphic, and that's just basically a shortcut for the people to look at the person who's in question and say, when did you last show up at a community service project or an office visit? And it's, hey, did you show up this month? Did you show up last month? Now, the graphic showed us that everything was filled in, so it was all good. But when we look at this, we see that here, for a chunk of people, we're not getting this code, we're getting some date, right? So if we didn't go look at this in advance, we might try to do some statistics or graph some stuff, and that's going to break us. So we've got to figure out why that is. When you talk to the client, turns out that was when they ran this data set, and whatever their query wasn't right, so they gave us some unclean data. But they told us, look, all you got to do is figure out the difference in time between when we ran this report, and we can fix that in Pandas really easily by doing this df apply with a lambda that just uses a little regex to replace this string with whatever the replacement value was. And so this is an example of a simple cleanup that was super easy, right? We got this dirty data that would have caught us up later. We were able to do a quick cleanup and get clean data that conforms to how the client looks at it. And I think you'll find, I don't know, in my experience, when you're going through this kind of stuff, there's lots of these one-off examples, right? You know, it's very rare that you're doing, you know, if you look at the PD apply examples in a lot of the lessons, they're like, oh, you take the value and you square it and it's super fast. Well, I don't have any of those happen in my projects. It's always like, here's a column and there's 10 things wrong with it, and you got to figure out a fix for each of those 10 things and apply it. But you can do that with this. All right. The next thing that I'll just touch on, I'm not going to talk about, is a correlation matrix. And a lot of times you'll see these, they list all the variables in pairwise comparison, and they're super useful. But they also can be a little bit confusing if you don't kind of know how to walk through them and how to build them. And so you can use the pandas function for doing a correlation matrix, and then you can use a little trick to overlay some white squares on the top half of the matrix, just to make it so that there's less to look at. And so this is what you end up with when you do that. Usually when you look at a correlation matrix, you know, one half along the axis is a mirror image of the other. It's just a lot to look at. Just put this white color or any other color you want over the top of it, and you're reducing the kind of stuff you have to think about to this kind of lower half. It just is a nice little trick to make it easier to kind of focus on what's important. So here we can see, hey, we have some positive correlation between the hours that the individual is paid, that's how many hours they've worked off, and the hours that they've billed. Maybe that's not a surprise. But there's a couple negative correlations in here. Now this data set's small, so it's not so confusing, but the approach of kind of just stripping out a lot of that duplicated visual stuff is very helpful. So hopefully you find that useful. All right, so the lessons on EDA, just to keep it clean, try the automatic graphical inspection. It's kind of magic, the missing no thing. There's several other APIs in that library that are great, depending on what you're looking at. And it's free. You just pop in your data frame, you get a result. If it's useful, great. If it's not, you can just move on to some other stuff. You still, though, will need to inspect your data. Like, you're never really going to get away from that. And that's important to make sure you don't break any downstream stuff. Okay? So that's the EDA piece. And let's move on to the next section. So now we're talking about getting into the project. We're going to talk a little bit about how we approached it. So the idea that we have these users and offices. We need to go locate all those people specifically because the client wants a map. They want to know how far away they are from each other, etc. And we're going to then take that data and make sure it's right. We're going to go use some API to make sure that all these locations are correct, because I don't know, you can't visually inspect it. There's tens of thousands of them. We're going to take all the errors from that validation, throw them out of the data set so we can make some progress, but in turn, we're also going to give those back to the client. We can say, hey, look, you had a bunch of users here with data from your source system that's not right. Maybe they're in postcodes that don't exist. Maybe there's a typo, misformatted, etc. And then finally, we'll use this Google distance matrix. Now, some limitations that were important to consider This API that we'll see in just a second, free, works well, not the fastest. So, you want to kind of think about how many times you're going to run against that. Google Distance Matrix, awesome, not free, right? So if you start looking at lots of pairwise combinations, you could rack up a big bill. So the strategy here that I use to minimize kind of the cost of my time and the time we're spending and how much we're spending on Google is like do an API, do it with samples of data, get it working, and run that all the way through the whole pipeline to get it working and make sure everything's working. And then productize it, then open it up and remove the samples and things like that. And that was useful because it helped me kind of explore the data and make sure that all the analysis was working. So here's the first piece for validating postcodes. Great API. Specifically, someone built a wrapper in Python to go to this public service and pull all kinds of data. It's in Python. It's very easy to call. And I, of course, used a couple other libraries here to kind of flatten it because everything you get out of these APIs is a JSON, and we want to work in data frames. So we've got to kind of get it down into a single row with columns. Okay. So the first function we'll talk about now is checking to make sure that these postcodes exist. And so what we'll do is we'll take a set of data, we'll get the postcodes for that, we'll pass it into this function. Once we've got that, we don't want to go check this API too many times if we don't need to. So we use the set function that strips out all the duplicates. We just got unique values. And then we go through that set one by one, go out to this postcode, and we say, hey, create a result for me and get me the JSON. And then when I look at that JSON, if it's not true, take that postcode and put it in the bad list, right? Because I want to get two separate lists here. And if it passes through that, then take that postcode and put it in the good list. And then give me back these two lists, the list of postcodes that are good, the list of postcodes that are bad. So pretty simple. Here's a little demo of how it works. We took a sample from this data frame, 20. It's running through that API. And hopefully in about a few seconds, it gives us back this list of postcodes. And there's the first live demo of some code here in our little talk. You can see that there's a couple of postcodes that just don't exist, and you can go out to the URLs that were in the previous cell and type them in, and you'll get the same result, right? So in the back end, we'll put those in a file to give to the client. The next thing we want to do is go get this enrichment data that we need for mapping, right? So we need to map some stuff. Postcode's not good enough. So what we're going to do is create another client using the same thing and go use a different API at this site using the same Python library. And this Python library is pretty awesome because the API actually provides a lot of different data elements that are relevant. I don't actually know what the Westminster parliamentary thing is. It's probably a voting thing or something like that. There's a lot of data in there. We don't really want to go get all that back, right? We just want to pick the specific things that our project needs. So we predefine a subset of these columns, and then we go and repeat this process where we basically get the API to go out and get a JSON for each postcode, get all this data. It's going to come back. It's going to flatten it. That means we squeeze that JSON into a row, and then we're going to stick that at the end of a brand new data frame and give this data frame back to our requester, right? So now we have this data frame with all the good postcodes and all this geo data. And with that, now we're kind of getting somewhere, like we can go and do some mapping. All right, let's see if it works. This worked before the talk. Let's see if it works now. So now we're going back, we're kind of running through all those functions for another random set of 20. And hopefully we'll get back a table like we just saw that has a list of fancy postcodes and longitudes and latitudes. So voila, there we now completed the second kind of live code. Very, very exciting. All right, so with that, we want to now take our way back to the root problem. The root problem is we want to basically go find ways to append all of this rich geographic data to, for instance, our source data, like our users or the offices. And that's what this does. This function just goes back in a series and grabs those previous functions and adds them to the data frame. Skip down one here. And another live demo here. This is gonna, I just put it in a loop so some stuff kicks out. This is going out, and on the left-hand side is all of the columns that were in that cleaned up user data, right? And on the right-hand side, you can see we've added in the latitude and longitude for that particular dummy user that we're talking about. And so now we have a new table of users with locations, and we can start doing things like mapping of distances and all that kind of stuff. And so what's interesting here is that, with just a couple of serial steps with some APIs, you can break a problem down into some kind of manageable bite-sized chunks, work with a little bit of data, get them working, and then feed it all into the rest of your program. So that iterative way of exploration is super. So the Google Distance Matrix API is actually very cool. It's essentially a programmatic way to get at the same thing you can get with Google Maps. And there's some documentation there. It used to be literally completely free. Now you actually have to put a credit card down, but there is, importantly, a monthly credit they give you, like a couple $100 a month. So you can still use it for very low volume test projects and stuff like that, right? I think $200, it's like $4 per 1,000 queries, something like that. So it's really, really nothing. And so you can run through a couple 100,000 of those in a month doing some development and not go over your limit, or at least not spend very much. There's 10 parameters you can include. The big ones, of course, are origin and destination. It looks for addresses, which you can use latitude and longitude. It needs to know when exactly you're traveling, right? So that's in this time since the epoch, and you can calculate that. And it needs to know kind of, do you want metric, do you want imperial, and how are you traveling? You can ask your user to drive, etc. For the purposes of this project, we use transit, which kind of is an umbrella term for any public transit, whether it's bus, subway, rail, commuter rail, whatever. So it's a cool API. It gives you back a JSON, looks like this. There are more kind of segments of this depending on kind of what you ask for. So we got to flatten this puppy. And let's presume that we know how to flatten it. But before we do that, we want to figure out, okay, I can find all the offices and put them on a map. I can find all the users and put them on a map. I can find all the projects and put them on a map. But the problem I'd like to solve is, which project or which office should I assign a particular person to? Because maybe the one we assign them to is full, right? As an example, they keep going to this project, it's full. Let's maybe find another one that's not full. Maybe there's a closer one, who knows? The only way to do that is kind of look at some pairwise distance comparison between these 2 points. Little obstacle we have, the user table has no corresponding keys in the project table. Doesn't have any corresponding keys in the office table. It could, but it wasn't in this data set. So we got to find a way to fix that. The standard pandas approach, it was very exciting when I first jumped onto it for this, doesn't work because there are no keys. So what are we going to do? We got to find a way to fix that. How we fix that? If pandas needs keys, we're going to give pandas some keys, right? So what we do is we basically find a way to create some temporary keys. And we pick the rows that we want to do. Essentially, we're replicating a cross join where we're multiplying these two matrices together. So we want the product of every row in the users table with, say, every row in the office table or every row in the project table. And a quick way to do that is basically read in one row from the users, append a temporary column to it with a key, and put a value in that, and do the same thing with this other table. And then pandas merge works great. Merge all those things together. That's what's happening here. We join them together. We recreate an index. And because we don't need this temp thing showing up in millions and millions of rows, we just drop those columns. And we return this result, the new data frame that's the product of those two matrices. Now, what's interesting about this is that, as it turns out, this function is great for putting in an apply function in pandas. And pandas has this function where you can apply a single function to everything in the matrix. So we've already got ourselves set up well so we can vectorize the lookups of all of these combinations. All right, now we're going to go map some stuff. Importing Google Maps. As I mentioned, Google Maps isn't free. You need an API key, please. Don't put it in your notebook. Don't put it in GitHub. Don't put it on a public repo. The people have done that. It can cost you a lot of money. Put it in your environment and then look it up. While we're doing that, we'll import this other library, Haversine, that basically does the Haversine distance, like the as the crow flies. It's another kind of freebie, lets us look at things in a slightly different way, and also is a nice proxy for distance. So we are now going to look at the function we wrote to calculate the distances and the times between these locations. So remember now we've combined our users and say our projects. So we have one user and one project, same user, another project, all the way through. And that's what Google needs. They need an origin and a destination. So we're going to give Google this transit mode and distance units and the origin data right here. There is a little bit of processing we have to do to make sure that we conform to the expectations of Google's API. They require 2 strings. And if you're giving them Latin long, they need to be separated by a space. So it's super easy to do. We create a dictionary. When we call the API, we're going to get the results back, and the results are going to have kind of extra stuff in the result. It's going to say 22.1 km. That just makes it harder to deal with. We know it's kilometers because we asked for metric. We just want the 22. So we do a couple things to strip out some of that extraneous stuff. And I like to put it in a single dictionary where I can just look at it and know that's what I'm getting. And so this was important for me as I went through this project to just have these kind of anchor points. This is the result I'm getting, and work my way back up and make sure it works all the way through. Now, because we're working in data frames, we need that in a row. So I'm going to strip all that stuff out into a list and pass all these results back. And so what does that give us? That gives us the transit times for a row, one point to another point that we can then tack onto the side. Any questions about that? No? All right. So let's see if this demo works here. Transit metric, hopefully we can change a couple things like a date, and let's see if this runs. This is going to go back and pull all of the stuff for another random set of 20 things, and we'll give it about 30 seconds. It was a little slow when I ran it before the session. While it's running, I'll just explain what's happening in this page. So we grabbed our data. We're defining some of these key values like arrival time, etc. So in the client's case here, when they're doing projects, the projects start at 9, right? So if you're not there at 9, doesn't count. You show up at 9:05, you don't get attendance count, right? So they're just very strict about that kind of stuff. And we want people to arrive before then, right? So we want to be able to tell people how far away it is and what time they might arrive. And so we'll go out and we'll create this single function that's a lambda that calls this Google distance function we just did. And when we get it back, we apply it to all the rows. We put those rows in columns kind of off to the right. I'm not sure why it's not done yet, so we'll just skip on and maybe it'll be done when we come back. Here's a subset of the data that came back the last time, just to give you a view of what we look at. Postcodes, the address of the office. Here's the distance as the crow flies, and then also the Google distance. So you can see that some of these are material, right? As the crow flies, may cross a river, may take longer for the subway to kind of go around and come up somewhere else, etc. And so what we have here is a way to kind of make some decisions about, what's in your neighborhood. You can use this Haversine distance to just get a general feel of what set of projects or offices are generally close to the person. You can use the Google one to get very specific times, very specific distances, and use that for a much more accurate choice about where people would prefer to go. So what we've done so far, to recap, we did a bunch of cleaning. We did some Cartesian joins of these data sets, and just to dimension it, the users in the office, if you look citywide at all of them, it's a couple 100,000, 250,000 kind of pairs to look at. The projects could be 11 or 12 million. Now, actually, we don't need to look at all the projects. We're not going to send a user, all the way across the city to work on something. But we could say, hey, give me projects within a 10-kilometer radius or something reasonable, And so this is what we've done in the background of all this. Now, maps were super interesting to the client because the data they had, they couldn't really map it. They generally kind of knew where the offices were and things like that, but they didn't know kind of just visually how they stacked up. Less so with the offices and more so with the projects. When you have a few hundred projects, it's actually kind of difficult to look at it and intuitively know. So we used a library called Folium. It's a Python library that embeds this JavaScript library called Leaflet, and it's great for mapping, right? You could also use Google Maps or something like that if you wanted to, Mapbox, etc. But this is a neat way to kind of get some quick visualizations. So what we did here, we imported all of our data. I said, let's make a map of this thing. We did some setup data. Okay, where do we want it to center? Let's pick like London Bridge. How zoomed in do we want to be? I turned off touch because every time I touched my screen, the map would go kind of flying everywhere. As it turns out, there's a number of different tiles, and tiles are essentially the visual style of the map, etc. And there's some free ones. You can also, if you have an API key for Mapbox or something like that, you could use that as well. And so how this works is this takes all those origins and destinations, passes them into Folium as an array, and puts markers down. So we first mapped all of the origins, and then for the users, because we had so many of them, we're going to create a heat map. And so what we'll see here is a map with points where the offices are, but a heat map of kind of where the people are, so we can get a feel for where everybody is. And here's our marker for the center of London, which I'm calling London Bridge. And when you go through this mapping of points, you can do some pretty interesting stuff. You can layer in metadata from any column in your data frame. So here, I gave it an icon, and I said, let's put the office name in there so that people get a feel for kind of what office is there. We'll map that stuff and see how it looks. Enter. Is it running? It is. And while we're waiting for that, I'm going to open up my next maps. These are the backup maps, should the first maps not be done. All right, so here's the map. I'll pull up the static one because it's here. Here's a map of the users and their office locations. And the first thing that I was interested to see, if you remember at the beginning of the project, I was told, these are all London people. What do you notice about the map? Does anybody notice anything odd about the map? I said, hey, what's going on with all these guys over here? And so there was a couple calls. Being in London, of course, they're always at like midnight or whatever, my time. And it turns out that this is news to the agency. These are people that should be assigned to other groups within the UK government that are responsible for different geographic areas, like Scotland, kind of they have their own bureau or something like that. And so there's a good outcome here, though, because what's happening is these folks are sitting in the London queue. Nobody's calling them because they're not assigned to an agent in London, and they're not finishing their community service or whatever. So that's not good for the person because now they're just racking up bad credit on the courts, right? And so how about we take these people and assign them to someone who's local to them who can sit with them and get them back on track and help them finish out their program. So that's already a good outcome. The client likes this because, well, they just get to play around, and again, they don't really have anything like this today. They're working with this green screen stuff in Excel. So the fact that they can quickly kind of get this messy data into something like this is exciting for them. And so they're able to look at this, and this may take a minute based on the network as it kind of pulls in the different tiles, but you can zoom in to all different points here. And they liked this quite a bit. This, for some reason, I don't know why my Jupyter notebook doesn't like it unless I do run all. So I'm going to have to do that again to show you the code did run. Great. So while that's cooking away, here's a map of the projects. So this is a different heat map looking at the projects that people are assigned to. And you can see within the UK, within the City of London, there's this huge cluster of projects, and it's kind of hard to make sense of it until you zoom in enough to figure out, what's happening in here. And I don't know why this is, I'm zooming in Folium or something like that. There we go. All right. I don't know why the zoom, I'm not sure what I'm zooming in on here. I think I have the, I'm sure you can. I haven't spent the time to figure out how to do that, but that's a good idea. So how the client's using this is they're using this to kind of look at kind of the overall distribution of users and projects and asking them questions like, is there a good reason that we don't have any projects in this area, right? Now that's super simple. The analysis that we're just starting is, well, what's the utilization of each of these projects? You know, it could be that all of these projects here are only 20, 30% full. Why is that? Maybe more users should be steered to those projects, or those projects should be collapsed, and the workers that run those projects could be moved to a different location so we can give better service to people, right? So that's kind of the takeaway. And that is basically the end of the talk. Here's the original map that I was trying to run. I'm not quite sure why it didn't pop up in the first time we ran it. Recap. I don't know. Too many clicks. Rolling down. I guess it doesn't like being full screen in Rise. That's a lesson learned. Okay, so that's the end of the talk. The big takeaway that I would leave you with is, in addition to kind of doing the automated data visualization and some of the cleanup and working with libraries like Missing No, when you're working with Jupyter, the iron rule is restart and run all, or it didn't happen. So as you may know, when you're working in Jupyter, it's very easy to lose state or to change state if you modify some of your code kind of halfway through the workbook. And so when you get through that piece, at the end, if you don't go through and run it all, you may find that you broke something in the middle and the rest of your code doesn't finish. So that's the end of the pitch. Hopefully you guys learned a few things about libraries that might be useful and how you can apply Python to help social causes. I think we have just a couple minutes. Are there any questions that I can answer? Oh, yes. Oh, okay. Oh, so the question is, just to repeat, I don't know if that mic is on. The question is, were we going out and computing the routes between point A and point B? With this API, no. This API does go out and look at those, for instance, for subway and driving, but it just returns kind of the total distance and the transit time, etc. There's another API, if you want, that will return a map object with the lines and all that kind of stuff that you can use. Yeah. Yeah. Well, what we're looking at right now actually is not a Google map. This map is an open source map. The library that runs it is called Folium. The tiles that we're using are from OpenStreetMap. And there's a few other free tiles in there, like Stamen has some and things like that. So you could take this same result and actually plug it into the Google Maps API and put this on Google. The difference would be probably a little faster response because of caching, and you get that nice Google logo in the bottom right corner. Yeah. Yes. Oh, yeah, we'll put slides up and stuff like that. I mean, without data, obviously, but we'll put some slides up with some sample data. Yeah, no, absolutely. Yeah, we'll do slides and public version on GitHub or something like that. So yeah, absolutely. All right. Voila.
All right. Oh, cool. Hi, my name is Ahsan Zhahid. I work as an Android engineer at a little healthcare tech startup called Vita Health out in downtown San Francisco. I'm going to be talking a little bit about GraphQL today. It's going to be kind of like an overview, a little bit of basics, and an example in Python at the very end. So GraphQL is a tool primarily used for making APIs. How many of you guys make APIs on the daily or semi-daily? So GraphQL is something that's supposed to try and make that a little bit easier. So instead of just jumping into code, I want to start by kind of explaining what the world is like right now. that brings us to the allegory of the restaurant, pun very much intended, or the state of APIs today. So here's the situation. You walk into a restaurant, you sit down, right? You're hungry, you want something to eat. So you call the waiter over. Call him over, he asks you, oh, what do you like? You say, you know what? I want a burger. I think a burger sounds pretty good. Waiter says to you, burger. No clue what that is. Can't help you. So you say, okay, I see some cheese in the back there. How about you bring me some cheese? I'll go for some cheese, we'll see where it goes from there. The waiter says, yeah, sure, I can get you some cheese. So you wait. You wait, and now you're old, and now you've got a beard, and now you're wearing a suit. I'm going to indulge as much as I can in my fondness for hipster stock photography throughout the talk. So now you're waiting, and now you're waiting for your cheese to come back, and eventually the waiter does come back, and he says, brought you your cheese. All right, step one, got some cheese. Now, next thing though, you call the waiter back, and you say, hey, I got the cheese, cool and all, but you know what, I want something else. How about you bring me some lettuce? And he says, oh yeah, lettuce, we got some lettuce. I'll bring you some lettuce. Okay, sweet. Now you're waiting again. Now you're messing around on your phone, still wearing a suit, still got a beard, nothing different, still waiting for your lettuce to come by. But you know what, this time you've wised up. You know what, this waiter's going to take a long time. You know what you could do instead is you could call another waiter to come by, which you do, and then you say, I'm waiting for a guy to get me some lettuce. Could he also bring me some tomatoes by any chance? You got those? And they say, yep, we got tomatoes. Bring you some tomatoes. Done. Cool. Send the waitress out to get tomatoes. Call someone else up. How about burger patties? Yeah, we got burger patties. Somehow they don't have burgers, but they have the patties. So you say, please bring me the burger patties. Sure. Friendly folk, they say, okay. And then you send one more waiter out to get you that bread, which also works out. So they've got the bread. And you know what? Now you're in business. Now you've got things coming. Things are happening. It's not so boring anymore. We'll see if you still got the beard. So your tomatoes come back. Perfect, another step out of the way. Your lettuce comes back. Another step out of the way. You're almost ready to eat now. You've got some sort of meat salad thing going on because your patty is back as well. So you thank all those waiters. Now, you are almost ready, but the buns haven't come back, and you can't really finish anything without those. So you're left waiting. Also, now you're female and you're sitting by a telephone. I guess the iPhone turned it into something else. So now you're waiting. You can't really do anything because you don't have all your ingredients yet, or at least not the main ingredient that you need to actually start eating your food. Right? Like if the lettuce was missing, I don't know, you could start putting stuff together and still eat it. Eventually, the bread does come through. The buns do come through. So you're feeling great. You got all the ingredients together. You have become the chef. You're ready to make your dinner. So you dust off your hands. You get to work. Put the lettuce together with the tomatoes and the cheese and the bun. And before you know it, you've got a burger. Sweet. Just what you wanted, although now you're probably too tired to actually enjoy it. But you know what? Congratulations. You did something. This is how REST primarily works. So REST is representational state transfer. The idea behind this is that your server is set up to give you resources of some sort. Here, they're ingredients for a burger. In an actual application, that might be user data, that might be any sort of resource models, pulled out from a database or something. If you have multiple resources that you need to do something, oftentimes you'll find yourself making multiple requests to multiple endpoints. So one endpoint might serve you one sort of data. If you have like a library API, one endpoint might give you one particular book. Another endpoint might allow you to put a new book on the shelf. Yet another endpoint might allow you to get all the books for a certain category or get them by Dewey Decimal. So you've got some sort of resources. If you need multiple, you make multiple requests. But then if you need data in a different configuration from what you have already, you have a few options. You can either create an entirely new endpoint that gets you data in that configuration. For example, let's say you've got like a user, but now not just the user, you need a specific user and you need that user's list of friends, and you need the other users that are that user's friends. So either you can get those things manually and recombine that data on the client side, which is what some people opt to do, or you could create an entirely separate endpoint that's no longer dedicated to just fetching a user or fetching a user and their list of friends, but this very particular configuration that you need. And people do it differently. Some people like to just have a bunch of endpoints and pull down data as they need it. Other people say, when it's too complicated, you might have a complex configuration of data being generated on the server, and you send that all down in a blob. Either way, when you need to add something new or your client needs a different configuration of data, maybe you're adding a new feature, oftentimes that involves a lot of API work, setting things up to get data and combine it together on the front end or on the back end. So that's primarily how REST works. And if you haven't worked a lot with APIs, what REST is, it's not just getting data from servers. We do that with requesting data with XML HTTP requests. So REST is this idea of having a few different verbs that dictate what you're doing with those resources. So if you send a post request, you're trying to create a resource, ideally. You can also send data about what you're trying to make. If you're trying to get some data, you send a GET request to the same endpoint, ideally. If you want to update something or replace an entire resource, use a put request, patch to modify, and then delete to delete. So in a blog, for example, how this would work is your resources would be your blog posts and comments. So if you wanted to get all the posts for a blog, maybe you would hit a GET endpoint. You would send a GET request to an endpoint. You get all the post data. Now, each post might have a list of comments. Instead of sending down all of those comments, you might just send down the IDs of those comments. And if you have those IDs, you can go to each of those IDs and you can send a new GET request for each comment to get that comment data down. Now, for each comment piece of data, you might have the ID of the user that made that comment. And if you want to, for example, display it underneath the blog, now you need to get the data for each of those users down. So as you can see, it ends up becoming a lot of requests back and forth, and then you combine that data all on your client side. So that ends up being a fair amount of work. So that brings us to the allegory of the restaurant part 2, or the shape of APIs to come. Here's how things work at a GraphQL-esque restaurant. So you come in, you're hungry, you want some food. Also, you happen to be female now, and you're sitting, you're waiting, you call a waiter over, you say, "Hey, I'd like a burger." Waiter says, "Burger? I don't know what that is. How do I get a burger?" But they say, "Here's a menu. I've got a menu for you. I don't know, point to what you want and I'll try to make it for you." So, still being female, but different now, you take a look at the menu and you say, "You know what? Bring me a burger bun, but inside of that put lettuce, cheese, and tomatoes and a patty. Put that together and then bring that over to me." You say this decisively. You're at a meeting now and you're very sure of what you want. You tell them, no holding back. The waiter says, "No problem, I've got you." You wait a little while, and before you know it, you have your burger. So this is a little bit simpler, makes a lot more sense, and everything is right with the world. And that's the idea behind GraphQL. And we're going to explore that a little bit now. So what is GraphQL itself? Now, so GraphQL is actually a specification for a query language. So don't think so much about the graph part as much as the query language part. Think like SQL. So SQL allows you to craft a query. That query can be parameterized or not. And then someone executes that query and gives you a bunch of data back. That's kind of the idea also behind GraphQL. Originally, it was made by Facebook. Now it's an open source project. And although it's a specification, there are implementations of GraphQL available for all sorts of platforms. Facebook has their own called Relay. A lot of these have both a front end and a back end component. Another really popular one is Apollo. You'll see that used all over the place for mobile and web and Node and React and stuff. And then there's also one we're going to be looking at later today called Graphene, which works really well for Python. So I was thinking about how exactly to explain GraphQL and give like an overview of it. But if you just go to graphql.org, front and center on the website, they have one of the most succinct explanations. So I want to just kind of take that and throw it onto a slide and make things bigger and show you. There are 3 main parts. You describe your data, you ask for what you want, and then you get results. So describing your data is done ahead of time. Instead of making several different endpoints for different configurations of data, you instead define what your data is. So it's very schema-driven. So you write a schema describing, here's what my data is, here's what the different types of data are, and here's how they're related. Very, very much kind of like you would do with like a relational database or SQL or something like that. You define your data, you say, here's how it's paired together. And then you also say, here's what's okay to start querying for. Then, once you have your schema written out, you need something to be able to actually accept queries on that schema. So if your schema says, hey, for example, that there's a type called projects, somewhere on your backend, you need a way to get projects. So this decouples it from any specific sort of database. So wherever you're getting your data doesn't really matter. If you've specified that there is such a thing as a project, whether that's coming out of a static JSON file or a Mongo database or out of a PostgreSQL database, does not matter. All that GraphQL cares about is that here's the type of data that you can expect, and then it's up to the backend implementing that schema to resolve that data somehow. Then on the front end, this is what the second thing there is what a query looks like. So if we know we have a project, our query just says, here's a project, we pass it a parameter. In this case, it's a name. The name of the project is GraphQL, and then inside of those brackets, we give it what data we want. So instead of the data that gets returned being defined ahead of time, we can tell in that query exactly what fields we'd like. The resulting data, which is that predictable results thing, looks like your query. So if you write a query in GraphQL, you send that up to an endpoint, the data that you're going to get back looks a whole lot like that query. So it makes sense what you would get back. So on the front end, there's not a lot of confusion about what that data is going to look like when it comes back. You know what the object is, you know what's inside of it, and you know where all the data is that you're looking for, which makes it so documentation pretty much comes free in GraphQL to some extent, just because of the way the data you get back looks a lot like what you asked for, which makes it much easier to write new APIs or to use your API to make new features in your software. So let's look at types for a second. So a type defines, well, a type of data, what you're expecting to get back. A field on a type describes like the value describing that data. So, like you have a post on like a blog, for example, one post might have an ID that's a string, a title that's a string, and then a date time where it was published, et cetera, et cetera. And you can see here that there are ways to define relations between these two. So a post might have the blog that it belongs to, and then a blog might have the posts contained under it. This sort of layout that you see here with the type post bracket, whatever, that is called the GraphQL schema definition language. This is kind of a language and platform agnostic way to talk about GraphQL. Not all the tools that implement GraphQL will actually use this exact language, but the idea still holds. There are some where you literally would put this in as a string and that's your schema. In other libraries, you have to use that library's own ways to generate that schema. But your types will often, not always, but often correspond with the actual models that you have in your web application or whatever sort of application. So if you have a project model in your application or in your database, it's easy enough to create a project type in your schema, and then you can start querying for that, and then you're off to the races. Next, let's look at an example of what a full schema looks like. Hopefully there's some understanding of what the entire thing is supposed to do. So let's take a look at this schema here. So, hold on 1 second. Let me mirror here. Okay, cool. Thanks. Okay, so every schema has two main things inside of it. There's the query type. The query type is the entry point into any query. So every query starts out as this query type. So in this case, our main query type is this root query type. So when you start querying, these are the only two things you can start with. You can either get a current user or you can get this billing object. But once you get that first thing, then you can start querying inside of that. So for example, this is like your root query, the root object you're going to get back. And then from there, you can ask for whatever data is contained inside of there or related to it. So if your root query got all of your users, you could start out with your root query getting your users, then the users getting a list of friends, getting users that correspond to those friends, and getting data, so on and so forth. Here are just some example types. In addition to querying for data, what you would usually do via like a post or a put, we have mutations in GraphQL. These work kind of like queries. The idea is that you send some data in, but then instead of giving you like existing data back, it does something and can return a result, much like a post request would. So instead of starting with a query, you would start with a mutation. Deleting things also you can write out as a mutation. So mutations are things like registering a user, registering, creating things, logging in, logging out, etc. So most of the things that you would do other than just getting data, you would do in a mutation. Anything where you just want to get a certain configuration of data, you can use a query for that. So that's what a schema looks like. You're defining everything that exists as part of your little GraphQL world and telling how it's connected to each other. Probably okay, not that exciting, but the exciting part comes when we actually start writing queries. So there's this very useful tool called FakerQL. This just gives you some data that exists that you can query. There's a GraphQL endpoint up that someone made. One of the cool things about GraphQL is this idea of introspection. You can ask a GraphQL endpoint what it can possibly get for you. That means that even if I know nothing about this GraphQL endpoint, I can start figuring my way out and I can start asking for data. What's open right now is called GraphQL Playground. There are a lot of these little one-off applications that just take a GraphQL endpoint and just let you shoot queries at it and see what the results are. Very, very useful for like debugging and finalizing your queries, and then you can get them from here and then put them into your actual application. So very, very useful debugging tool. So like I said before, your root thing has to be a query before getting data. Now from here, we can just use autocomplete and we can see what's available here. So this is through the power of introspection. Let's say that I want to get all users, because there are apparently users here. And then what do I want to get for all of the users? Autocomplete again, I could get the ID. Sure. What else can I get? I can get the first name. And now if I run this query, look at that. Just like on this side, I've got the ID and the first name by those exact JSON keys, and I've got them in a tidy little array called all users. So if you're going to be reconfiguring data a lot in different parts of your application, and the only thing changing is the level of nesting, or you need one user versus all of them, this lets you send one request, one query, get all of the data that you need at once in the right configuration, and then you can just continue working on whatever your application logic is doing. Other cool thing is that instead of just taking the name that it gives back to you, you can rename it. So you can say everyone. And then we can now, instead, your object is called everyone. So in addition to just getting the data back, you can give the proper key names, whatever your application expects. So instead of your server having to configure everything the way that one particular screen of your web application needs, you can let the client say, here's what I need, figure it out for me, and give me the data that I can use. So we can, you can just kind of go nuts with this. What else is there? There's a last name. We can get last names. What else is there? There's emails and avatars. Fun stuff is when you can do things like all products, do relational stuff, all the product prices. So let's say we want an ID for a particular product. So that's one other use case. So let's say we have this ID here for this product, whatever it might be. If we wanted to get just that one product, maybe for like a product detail screen, we can hit up the product query. We can say the ID, paste that in right there. And then for that one product, maybe we want to get all the details. So the ID, the price, as well as the name. There, and now you've got like the data that you would need for that product details page versus before for maybe like a product search page. All without having to modify your backend one endpoint to manage. So long as you can deal with the schema stuff, makes things much easier and much smoother to work with. The other really useful place GraphQL fits in is for things like React applications. Oftentimes, if you're using Redux, sometimes you're using it literally just to wait till all the data has come in. Wait for like 3 or 4 requests to fire, come back, check if you're authorized, and then you can like start actually running your application logic. What some people do is they'll use GraphQL on the back end, and on the front end, since all your data is coming in at once, half of the need for something like Redux, unless you're using it to architecture and structure your application, half the need just kind of falls away because all your data is coming in at once. You don't have to wait for stuff. You don't have to like see if something's loading, fetching, and gotten for 3 or 4 pieces of data, and then wait, till when your actual application can load. So introspection is useful, and this is what a GraphQL query looks like, and you can get data back. Okay, so useful places to look into GraphQL further are the GraphQL.org website. This is all about the specification, not any one specific implementation. More useful, though, for us is Graphene, which is a Python GraphQL implementation. So you can use this to create a Python GraphQL endpoint. There are plugins to use this inside of Relay and Django. The example in particular that I'm going to show you guys is for Django. So if you have a web application written in Django, you can start using GraphQL alongside existing REST APIs. So let's take a quick look at that. All right, sweet. Is that visible? Okay, cool. So here we just have a simple Django project. I have this thing called Ingredients here. So it's a cookbook. Our app is called Ingredients. So we have to create a schema. So like before, instead of using SDL, you have to use a bunch of their Python classes. So the main query in our schema just takes from the app's ingredient schema query and then Graphene's regular object type. So the outermost thing you can get is this query type. And that query type lets you get the query from the actual ingredients. So inside of here, so here's that main query type. And we've got 2 lists that you can get. You can either get all of the categories or all of the ingredients. So our outermost thing is all categories or all ingredients. And then for one ingredient, you could start to get more data. Or for one category, maybe you could start getting the ingredients in that category. So we have 2 entry points into our little GraphQL world. So although this is schema related, the next thing is actually if someone asks for all the categories, how do we actually get those to them? And in GraphQL, we call those resolvers. So a resolver function tells you how to actually get data if someone asks for a certain type of data. In our case, we have this all categories. So if we resolve all categories, we're just going to get all of the categories. This is set up with a simple SQLite database. And there's a fixture with some JSON. So we have dairy, meat, eggs, milk as sort of categories. And then we have actual ingredients in here. So we use the schema to tell how to get the categories and ingredients. And then and also we define the actual category type. And we say what model it actually represents. Okay. And then in addition, in Django, we also have models for categories and ingredients to actually get them and handle them. So the useful thing here is that in URLs, we've got this one GraphQL endpoint. And if we hit this on localhost, it'll take us to another one of those visual debugging tools. So if we go to localhost :8000/GraphQL, make sure that is indeed running. So I'm just running this. This is just based off the Django tutorial you can find here. So if you find Graphene Django, this is exactly what we're going through right now. So if that server is running, so here's Graphical. This is another thing like GraphQL Playground. It lets you select a GraphQL endpoint, shoot queries at it, and then get data back. Just like before, thanks to the power of introspection, we just say, hey, we want a query. We can say, okay, what can I query? So we can get all categories or all ingredients. We start with all categories. What's in a category? An ID. Let's get the ID, and let's get a name. So here are the 2 categories. We have dairy and meat. Okay, now for the relational stuff. So for a category, we can get the ingredients in that category. And now these ingredients aren't a scalar type. These other things like a string and ID, those are scalar types. Those are like the core data that we're looking for. But now ingredients are a whole separate type altogether. So if we're querying for ingredients here and we're expecting to get a bunch of different types of data back, we've got to tell it what fields on the ingredient type do we want. So we'll tell them. Maybe for each ingredient, we want the ID. Now, in addition to just the categories, we also have a sublist of the ingredients here. And we can treat those ingredients exactly like we treated, the categories. Whatever data is available there, we can go and get them. Get the name of the ingredient, get any notes associated with it, and there we go. So we can get as much or as little data as we'd like. There are all sorts of operations you can do. You can limit the amount of data that you get. You can implement things like pagination. But the core idea is that instead of rearranging things on the back end for every new configuration of data that you'd like, you set everything up once, you set up your schemas, you wire everything up, and then from the front end, you just say, here's the data I want, here's the configuration it should be in. In fact, here are the names of the keys that I want. Maybe for a particular part of your application, the data set is called something. You can tell it what you're expecting. It'll give you back exactly what you asked it for, and then you can begin to consume that data. Okay, so that's the overall idea of how GraphQL works. You can use Python for it. Encourage you to explore the graphene library and all the stuff available there. You can go much deeper into this. Just about anything that you would need to do in a REST-based API, you can do here. But hopefully using GraphQL makes it easier to add new things, makes it so you don't have to spin up new endpoints as often, and just make building APIs more pleasant in general. Let's see, there are a lot of public GraphQL APIs available, so if you want to just play around with this instead of building your own API, there's all sorts of stuff you can get an API key for and mess around with querying, or set up a simple, like a React application or something, install Apollo, and then start querying some of these endpoints. Yelp has one, though it wasn't working last I tried it. There's one here for getting Pokemon, which is kind of cool. So you can start asking this for, the repo for that. You can start getting the actual data that you'd like from here. We have a query. We can get a Pokemon. You need a number of some sort. What's the number? 1? Let's get the, where's the name? Name? Let's see if this works. There's the run button. Is that the run button? That is a run button. Number 1 is Bulbasaur. Cool. So then you can say, all right, well, what are the evolutions of this Pokemon? And what do the evolutions give back? Those are going to give back other Pokemon. So now we've got to say, what do we want about those evolutions? Or actually, evolutions need to be, we can get the actual Pokemon reference for them. And now for that Pokemon, we can get whatever else. We can get, I don't know, the name. Need the name for sure. Let's get the abilities. Oh, also, this is another separate thing. Page info, edges. What's an ability? Okay. I need to put a comma there. Let's see. Field abilities must have a subselection. Ability edge? Node? Okay, I think maybe they didn't finish this part of this. Trouble with live coding. I wasn't going to do it, but I ended up doing it anyways. Okay, let's just go with the Pokemon that the evolutions have here. Oh, never mind. Something else didn't work. Either way, concept holds. We'll just back away from that slowly. Okay, so the idea is, that's the overall idea with GraphQL. You set everything up ahead of time, regardless of where your data is coming from. You tell it how to expect and how to get data. And then on the front end, you just ask for what you want, and then you receive it. And that is all. Thank you very much. Happy holidays.
In the essence of time, what I'd like to do is, for other questions for both speakers, come right over here. We can actually finish and have lots of questions and answers. I'm actually very curious about the evolution of a couple of Pokemon, but I'm going to wait on that. If you have asked about, hey, I want to find a job, hey, I want to hire someone, right back at that food table, because that's where I'm going to be. So anyhow, those are the two places to be. Otherwise, find someone in the room, say hello, and I will see you next year.